Hi, everyone, and thank you for joining us today for our third and final installment of our AIA Certified webinar series. Today's webinar is Continuous Insulation, Building Envelope Design, and my name is Kim Melton, and I will be the moderator for today's presentation. Before we get to the introductions, I would like to go over a few logistics. First and foremost is that we're working from home. So if we run into any technical difficulties today, please bear with us. We will take about 5 minutes to try to address those technical difficulties. If we are not able to correct them in that 5 minutes, we're going to cancel today's presentation and we will reschedule for a later date when we can actually address the technical difficulties. We will be answering questions at the end of the webinar today. So if you'd like to submit a question, you should see that via the Q&A on the right side of your screen. Now, if you don't see a Q&A up there, you'll have a series of circular icons across the middle of your screen, and there's one with a little question mark on it. If you click on that question mark that's in the box there, it will open up the dialog box that you can use to submit questions. Also, today's webinar is for educational purposes only, and it should not be used as a substitute for professional engineering design, consultation, or documentation that might be required by your building codes, contracts, or applicable laws. So if you have any questions after the webinar, you can refer to our specific application guidelines and instructions located on the product sections of our website. You can also reach out to us directly, and we would be happy to address any questions that you may have. Additionally, we'll be following today's webinar with a survey, and this is your opportunity to provide us with feedback on how we did today. You can even use it to ask any additional questions you might have about the topic of the webinar or suggest new topics for future webinars you'd like to see. But this survey is also part of how we deliver the JAME experience to you. And if you look in the bottom left corner of your screen there, you'll see 4 values, and those are people, passion, perform, and protect. And these are really the core values of the JAME experience. And we offer webinars like this one today to provide a tool and a resource for the industry, but really making sure these are helpful to you isn't just a one-way street. So we use your feedback in the surveys to make sure that our webinars are providing the valuable educational content that you need for your business to thrive and do better. So we're also frequently asked whether or not we send out these presentations upon their conclusion. And while we won't send out the presentation itself, we are going to post a recording of it online. This will allow you to watch it at your leisure or share it with your colleagues, but you can also get it within its full context. And we'll send an email to you when that is live on the website. So with that, I am going to hand the ball over to your presenter today, and that is Jerry Fox, to introduce himself.
Thank you, Kim. I appreciate that. Good afternoon, everyone. I hope this message finds you well, and hope that everyone's staying healthy and safe. My name is Jerry Fox. I am a regional builder specialist for Johns Manville, and I have been with the company for over 5 years, traveling around and offering educational opportunities such as this webinar and other subjects around the nation. So we'll get started here. This is an AIA presentation. It is eligible for 1 learning unit HSW hour. If you had registered and provided us with your AIA number, we will log in the credit for you. This course, just as a quick description, this is dealing with commercial and residential construction. The continuous installation is really no longer an exception. It's becoming more of a norm as the National Energy Code for Buildings and the International Code Council and other organizations are setting higher efficiency requirements. The industry continues to recognize the role building enclosures play and in the overall performance. And continuing insulation is often being used in conjunction with traditional insulation. This course will provide an overview with continuous insulation and how continuous insulation addresses several building envelope design challenges, applications, and product considerations for various structures. The learning objectives, actually to be able to define what a thermal bridge is, identify the types and describe their impact on a building, define continuous insulation, what different kinds there are available to you, and the functions as well. Understand how to achieve an energy code compliance with continuous insulation, and then identify applications of continuous insulation and how those applications impact the building systems itself. You may recognize this chart as something very similar. it is definitely worth reviewing to kind of set a precedence here for this presentation. With the energy that is produced in the United States, the consumption just by buildings alone roughly estimates to be around 40 to 45%. If we look at the breakdown residentially, the energy consumption is around a little over 20%, and commercially a little over 18%. In the commercial realm, around 36% of the energy is used for space heating and cooling for the environment for comfort levels. Residentially, you'll notice that same space heating and cooling takes up about 50% of the energy being produced that we utilize in our buildings. So this begs the question, why is so much energy being used in our buildings? We're designing our buildings with better design scenarios, better materials, but there's still some areas that we can address. Some of the reasons that we're using so much energy is simply from thermal bridging. There's really not a definition from a code or ASHRAE officially, but we can use this definition to get an understanding of what thermal bridging really means. It's elements in the building assembly with relatively higher thermal conductivity than the surrounding materials, which allow heat to bypass through or bypass the thermal insulation. With these infrared images, you'll notice that there's some darker colors and some bright colors. The infrared images actually indicate the brighter light yellow or orange colors are the conductive materials that are showing up, and that is actually transmitting energy from a building to the exterior. And in both of these images, it is pretty apparent. A similar situation for residential, like we said, more energy is used in residential, so this is a pretty good indicator where we can actually see the actual structure glowing as the thermal energy or the energy inside is bridging through the actual structure itself. When it comes to structure and thermal bridging, if you take in consideration how a wall is constructed, a wall with studs, regardless if it's wood, steel, they would typically be comprised of about 25% of the wall being an actual framing member. Therefore, the other 75% would be roughly insulation if you're using insulation in between the cavities. Here are a few examples of some structural members. Sometimes in the designs, the structure actually protrudes outside the building. It's a continuation. For instance, these fins or balconies, if you will, that are cantilever concrete are actually an extension of the actual structure. And if we look at that in an infrared camera again, you'll notice that, of course, these bright colors are, again, that energy that is being transmitted or conducted, again, outside the building and outside the building from a warmer environment to a cooler environment in this particular case. If we look at framing in itself and we compare the resistance values of framing materials versus insulation materials, you'll notice that when we have our framing materials, that they are, for instance, wood is 3.5 times more conductive than fiberglass insulation or bad insulation inside the walls. If we continue to look at concrete, we're looking at another 35 times more conductive. Steel ends up being 1,400 times more conductive, and if we use aluminum studs, that actually exceeds 4,000 times. So the conductivity of the material, as you can see, is apparent, and we need to come up with a solution so that we're able to have a solution for this issue. Some of the issues that occur and a common problem with these framing materials are that they can create cold spots or cold surfaces, which actually can really affect the actual performance of the building, not only just thermally, but also severely impact the comfort, indoor air quality as well. If you notice in these areas, in corners where we have a gang of studs or around windows and doors, we could typically have a lot of thermal drive coming from the exterior into the cooler parts of a building, which would basically cool down these particular spots. Not only in corners and windows, but behind furnishings and closets where air circulation is not as prevalent and you don't get a lot of air circulation. You can begin to create these cooler spots, which would then create condensation in wall systems, which we all know that over time could be detrimental, and it could begin to affect us with mold and mildew growth. So in thermal bridging, we put a little chart together, and this is a calculation chart based off of the ASHRAE calculation methods. These are the components of a wall, meaning that in this particular column it is a wood structure. The one to the right is actually a steel structure, and we take each one of these components and we put everything in these systems so that everything's equal from the outside film, cladding, continuous insulation, exterior sheathing, framing, cavity insulation, interior gypsum, and interior air film. In this particular case, we're leaving out the continuous insulation for this example, just to show you that if you're trying to calculate an R value of an actual assembly between the framing and the wood, the framing and the cavity, you would add these results up. The only difference here is that we have a U value in the second to the last line of this chart, which is the inverse of the R value. But we're basically taking these calculations to figure out what the effective assembly R value would be from the actual assembly of this wall. And in a wood wall, if we were to take a look, even though we have a cavity insulation of R13 without any continuous insulation, we would actually end up with an 11.9, R value of 11.9, just shy of 12. If we take that same situation and we have in a steel structure, it would end up with an R of 8.1. Now, we're going to come back and take a look at this chart in a bit, just to kind of review this, but you can see that you're losing a lot of energy, again, through the framing itself. Continuous insulation is not necessarily new in the building industry. It's been around since the 1900s. It evolved around the refrigeration industry, and if you've heard of anyone referred to, and I'll use this example occasionally as an ice box instead of a refrigerator, back in the day, I know that my grandmother had an ice box, and they would have to produce ice in a building and then transport it so that they could preserve food. But that was before we had actual refrigerators. So back in the early 1900s, they would actually utilize this continuous insulation to contain as much of the cold air as they could possibly contain to produce this ice. In the 40s, we introduced continuous insulation for low-slope roofs, and we did this not just to insulate, but also to create drainage planes so that we can positively drain roof systems and have the water exit the actual building itself. Lately, code changes are now beginning to address this framing issue, as we've kind of already pointed out some of the issues that we're finding. And so now some of the codes are actually beginning to come up with some scenarios to help us with solutions. According to ASHRAE 90.1, the continuous insulation definition is insulation is applied across all structural members without thermal bridges other than fasteners and service openings. Now, the insulation can be installed on the interior or exterior, or as an integral part of an opaque surface of the building envelope. Continuous insulation comes in a number of different forms, rigid boards, mineral wool, spray foam applications, and each one of these have different characteristics, which we'll review here in just a bit. But here's some typical examples of what we'll see out in the field. Rigid boards are typically comprised of either a polystyrene material or a polyisocyanurate material. It definitely is available in different thicknesses to achieve an R value. Closed cell spray foam also is a good option. It holds definitely different characteristics of boards and the other components or the other options here. But mineral wool is a very popular option as well. Other options that you may be able to have options for are fiberglass boards, fiber boards, EFIS, insulated panels, SIPS panels. Those are all pretty popular in the industry as well. So just as a comparison, when it comes to the materials themselves, some different materials will yield different results, but when it comes to satisfying drainage planes, as you can see, EPS and XPS are the polystyrenes, the polyiso is here in the center. This stands for exterior closed cell spray foam, and then of course mineral wool products. The drainage planes, if you're trying to create a drainage plane behind your cladding material, in certain cases it says with tape. That means that you would have to apply a tape in order to seal the joints and the butt joints as the sheathing is being applied. Also, you'd need to seal around any penetrations as well. Certain materials would not necessarily be ideal for drainage planes. Mineral wool, specifically, it says no. This mineral wool is a great material, and water really doesn't affect it at all, to be honest with you. It won't absorb moisture, but if moisture were to either touch mineral wool or saturate, it would typically beat up and run down, or if it does saturate and penetrate the outside layer, it typically drains pretty easily and dries out relatively quickly. All the materials are acceptable to be used below grade. In the vapor retarder, this is a 1-inch scenario. Everyone's pretty much at a 1-inch application to be compared. But vapor retarders in itself, some are basically, some of these materials such as are more open, and some of them actually are closed. And the higher numbers are actually more permeable open. If you'll see, mineral wool, again, is not necessarily a drainage plane, so therefore it's not a good vapor retarder. You can apply a vapor retarder behind it, but when it comes to exterior spray foams, they do a good job actually with permeability, and so does the polyiso boards, and as you can see, the polystyrenes as well. For air barrier considerations, there are a couple of considerations to make here. If you're using some of the board materials such as polystyrene XPS or a polyiso, it would be a good idea to use a tape to create that air barrier. If you're using closed cell spray foam, it actually creates its own air barrier. If you are looking at some of the other materials, you can actually, with EPS, is actually not an approved air barrier. And these approved air barriers are, approved by the Air Barrier Association of America. That's what the ABA stands for. R value-wise, each one of these actually hosts a different variety of R values, which then in turn, if you're trying to reach an R value specifically on the exterior, you would have to adjust the thickness in order to meet that. And then as far as wind is concerned, there's a number of different tests that manufacturers apply for and either pass or and can provide data for you to help you, assist you if you're in a wind zone. Fire, we're going to talk about a bit more here in the near future, but there are differences in fire ratings as well. Some of the polystyrene products actually melt pretty quickly, which we'll review in a bit. Polyisos and some of the materials here with the plastic base are actually will char, but will retain its shape. Mineral, it does actually act as the best fire resistant material in the market for continuous installations. Basically, it is a non-combustible made of a volcanic rock. So with continuous installation wall types, you can apply this continuous installation across a number of different wall types and a number of different framing materials, regardless if you're using masonry, veneer, or panelized metal panels, ceramics, fiber cements. All of these materials will be compatible in different variations and thicknesses. Would be you'd be able to achieve a continuous installation behind all of these cladding systems. So interior wall types. We mentioned earlier that you can use the continuous installation on the exterior, which is typical. A lot of folks design the continuous installation systems to be installed on the exterior of the buildings, but you can also install it on the interior. We see this a lot with historical restorations when you're unable to manipulate the exterior of the building if you for like historical buildings that need to preserve that exterior appearance. But if you are to use it for like a tilt-up wall system, you can actually apply interior application of continuous insulation. And in the interior, the insulation actually can be left exposed if desired. So that's you just have to consider the fire code scenarios that you're designing for. So you have to take that in consideration on how to treat for interior insulation. Here's our chart again that we're going to revisit. Again, we kind of went through this earlier. What we're doing is just showing the scenario, the past scenario of not adding a continuous insulation option in your wall system. Again, we were in with a wood stud. We were at 11.9. In this scenario to the right, if we were to add an R3 of continuous insulation to the exterior of the system, which actually equates to a half-inch of a polyiso board, if you will. So by adding a half-inch to get an R3, we actually end up with an R15.3 in these wall scenarios. That's an increase of 3.4. So that definitely does help with the thermal drive. And if we look at the steel stud scenario, this is for steel studs. If you recall, the first case without continuous insulation, we yielded an R8.1. But in the steel stud, if we add the R3 across the framing on the exterior, we end up with a 12.6, and that's an additional 4.5. So as you can see, we're blocking that thermal drive from occurring and definitely improving the resistance of the wall and making the building more efficient. So here are a couple of examples. In this particular example, how does it work, and why does it make such a significant difference? It does make a significant difference if we were to look in a cold climate where the exterior of the building is extremely cold. We have a humidity factor on the exterior. On the interior, we're warming up the interior of the building. We're actually decreasing the relative humidity as well. But when the relative humidity meets the air temperature, that's when dew point would occur, and that's when you would be able to begin to seek a collection of condensation. So if you look at this scenario without any continuous insulation being a cladding surface, a vapor barrier, and then a building paper and then an OSB layer without the cavity insulation, the condensation would begin to collect on the exterior side of the building, and typically we see this collecting on the inside of the wall. Now, you can imagine that if this collection were to occur on the inside of the wall, there would be some problems or some issues that would develop over time with saturating that wall scenario. By adding the continuous insulation and moving that dew point to the exterior side of the building, what we're doing now is collecting, and if there's any condensation that would occur with that relative humidity meeting the air temperature, it would meet it on the exterior of the building, which is where we want the water and moisture to be, so that we can take advantage of that with our flashings and our details and remove the moisture from the building itself. So here's a scenario just the opposite. It's basically a warmer climate, and we have a warm, humid outside temperature and humidity level. It's a very high humidity level. But we're air conditioning or conditioning the space on the inside, cooling the air temperature down and removing some of that humidity. But really that vapor drive is trying to drive through without a continuous insulation air barrier. It's driving through into this cavity and now collecting moisture, or condensing, if you will, and the condensation collecting on the outside of the board, the gypsum board or wall board from inside. Again, if we were to add that continuous insulation in, it does adjust the dew point in the entire system, and therefore drives that moisture to the outside of the building, which is, again, where we want for our flashing and details to take over. So with air barriers as well, you're wanting to introduce air barriers in your system. You're basically, when you have your mechanical system in, and your air barrier needs to be continuous all the way across the envelope. Due to air infiltration, exfiltration, depending on what you're introducing, whether it be stack effect, wind effect, or a fan pressure, what you're trying to do is with these scenarios, the capability of carrying significant amount of heat and moisture into the wall system. And this will result in, again, the potential for structural damage and reduce thermal performance. One ideal approach is to consider using both an air barrier on both an internal and external wall assemblies. But be very careful, make sure that one of those air barriers are vapor permeable so that you're allowing that wall system to dry as the moisture or the humidity levels change and move through the wall system. So it's extremely important. You don't want to create too closed systems where you have a moisture sandwich. You want to be able to have those have one of those be permeable so it can dry out. So WRBs are water-resistant barriers. A lot of these materials that we're talking about as far as continuous insulation can also dual as a water-resistant barrier, an air barrier as well. One example of this is on the bottom picture. There's a foil-faced board with a taped joint. If you recall, we just referred to taping the joints of a board. This is an example of this job is being taped with the joints being abutted together, but also they're taping over the fasteners to prevent any air or water to be able to penetrate the system. In this scenario, you'd also want to tape any penetrations or seal off any penetrations as well, so that you have everything encapsulated. The picture at the top is an example of a mineral wool product, and as you can see, again, mineral wool is not an air barrier, it's more of a rain screen, and so therefore they've applied an additional water resistant barrier behind the mineral wool, and that actually that sheathing, that black color sheathing or that black material is actually acting as the air barrier and the WRB. And as far as some aesthetic concerns that we've noticed in the industry, a lot of times some of the continuous installation options are either colored or printed on, and sometimes you will see through or in between the actual connections or the claddings, if you will, the cladding joints. And so often you'll see a print or a color come shining through. And when you back away from the building, it gets pretty noticeable. Mineral actually has a more natural color to it, so it kind of fades away in the background a bit, and it's not nearly as noticeable, and it's pretty consistent in the joints. So with cladding systems, a couple of areas of concern are creating thermal breaks. If we're applying masonry or a metal clad system, and we're applying here, as you can see, an exterior continuous insulation board, but we still have to have a structure to attach our metal, let's say our metal cladding system to. Or here in the masonry, we're using a brick ledge here to lay the brick veneer in place. And in those scenarios, we want to separate, take an opportunity to separate so that we don't have a thermal bridge or create a thermal bridge between the two structures. And in doing that, there are options that are available to us. A lot of times when we look at these scenarios and options, they'll have special materials on the outside or around some of these structures to thermally break or give a thermal isolation, if you will, barrier between the two structures. Another option, if you look some other materials that are out in the market, will actually use a fiberglass thermal break as well. And again, just by that separation, not only does it create an air gap to allow moisture to drain out and again being taken away from the buildings from your flashing details, but it also separates the two structures so that we're not transmitting heat from the exterior to the in or cold air either way, either option, and depending on your climate. So looking at fire codes, just addressing some of the concerns on fire codes. Generally speaking, the NFPA 285 is one of the more recent concerns in the market, and it's triggered when you try to use a combustible material in a building that requires non-combustible exterior types, and this really doesn't matter what construction type you're actually categorizing. Your structure, it really does apply to all types. There are some scenarios where it would depend on the type and the height of the building or the number of stories, which we can explore a bit. But just an example, with NFPA 285, it is an actual assembly test. So you would have to actually have the entire assembly tested, everything from the exterior, from the framing itself, out to the cladding as well. So what we're doing is trying to protect everything from the air and water barrier systems, any type of foam plastic insulations, or any combustible claddings that we might have, whether that be an EFIS or MCM or any other kind of panels that we might put out or combustible materials that we might have on the exterior of the building. So we always get this question, well, do I need to meet an NFPA 285 for my building type? And we've got some information to share with you here. But just in general, foam plastics and wall assemblies for any building height is susceptible, so we have to make sure it meets the requirements to pass the NFPA 285 assembly. All exterior walls incorporating foam plastics, except the one-story buildings, as long as they have a sprinkler system, would qualify. Again, combustible claddings over 40 feet, fiberglass reinforced, over 2 stories. and then any kind of combustible wall materials that are over 40 feet as well. So here's an example of an actual, as far as the test itself, this is one that's actually being tested as you see in the picture. But these testing assemblies, again, are required to measure the flame propagation through the exterior wall system. It is non-analogous to UL hourly rating, and it can't be substituted for UL requirements. So it's an independent test. UL is an extremely important testing option, but NFPA 285 definitely addresses the exterior assembly itself. So measuring the fire propagation, the test actually has to withstand and run for 35 minutes. Individual products, all the individual products must be approved, but it has to be a part of the actual assembly. Occasionally we have questions about this. Well, hey, what if I value engineer or substitute out a material in this particular assembly? And that's always a very sticky question. And I simply always ask, who wants to take responsibility for that? So my suggestion is if you have an assembly that is approved, use the assembly. If you start mixing and matching or substituting in, you begin to play around with some unknowns, and then potentially could have a huge impact on the safety of a building. You probably have already heard, the Grenfell Tower fire in London was one of the reasons this was really taken effect. But Grenfell hasn't been the only fire out there, and I've looked at the NFPA website, and they've got some articles that are really interesting that pick out fires that have occurred, in Dubai, here in the United States. So it is definitely something that we have to pay attention to and be able to address. Here's a good example of an actual assembly being tested. And when this test is being conducted, there's a report that is also an evaluation report that is also available that you're able to receive as a part of the notification that the test has passed. But it gets down to the detail of the actual type of exterior materials, insulation, any type of boards that you're putting in, even the airspace. The distance of the airspace makes a huge difference as well. So you're going to get get the details of the actual assembly that's been tested and approved. So as we look at the sheathings themselves, there's a number of options on the market. Definitely have lots of considerations to make. We have thermal sets, which are actually in the process of making thermal sets. The polymers of the actual material itself, and this is like a polyiso board, ISO, if some people call it ISO boards, but those polymers actually interlock to each other during the curing process, and this helps to maintain its shape and stay intact. It will char, but it does typically remain in shape. Thermoplastics are a little different. Those are like polystyrene boards. They do have a very low temperature for softening at 165 degrees. But they begin to melt at 200 degrees. And then once they begin melting, they actually will begin to liquefy and then continue to burn. So with that consideration, at 200 degrees is not a very hot fire. That's actually a pretty low temperature fire, but it's hot molting liquid falling through the cavity of a wall system as you're trying to escape is not an idea that I would want to, or a scenario that I would want to be in the middle of. Mineral wool or mineral fiber, some folks call mineral fiber, but mineral wool is non-combustible. It definitely has the best fire performance of all the continuous insulation materials, and it holds up. I think the melting point of mineral wool is upwards of 2,100 degrees. And so once you reach those temperatures, there's more concerns than the exterior cladding system. So when it comes to the actual system that you're putting together as a design professional, it's especially critical to consider the water-resistant barriers, the air barrier applications. As we've pointed out here, your mechanical systems also are something to consider. How you're exchanging air in a building and how you're controlling that as well. The devil is truly in the details, architecturally and in the manufacturer's details as well, to make sure that the thermal performance is being met. Because they can change the way wall systems are built as far as how you're carefully detailing and what materials you're using and how you're applying them. So it really comes down to the designer of record to make sure that those details are meeting the requirements that you're trying to achieve. Again, there are third-party sources out there, the Air Barrier Association of America, which is a third party that will help designate what is an appropriate air barrier. And then there's also foam sheathing committees out there as well. So if you're looking for other third-party sources. So we've covered quite a bit of material here on thermal bridge, defining what thermal bridges are, what types of thermal bridges can occur, and some of the negative impacts that actually could affect the comfort level of the building. What a continuous insulation would be, what types or options you have out in the market, and some of the properties that would affect some of the decision making or what you're trying to achieve in your design. Energy code compliances, we've looked at applications. Again, continuous insulation can be installed in the interior or exterior depending on your building type or the scenario. We looked at water-resistant barriers. We've discussed what air barriers and water-resistant barriers, how important they are in the systems, and then just some building code considerations. And we reviewed some NFPA 285 information as well. One thing I'd like to share with you guys that I came across recently when doing some research on NFPA 285 website. There's an opportunity if you'd like to log in, and it's free of charge to create an account on NFPA if you don't have one already. But they have an opportunity to offer you an interactive tool that allows you to decode what systems or what the requirements would be to meet an NFPA 285. And it's a very difficult question to answer simply because there's so many different scenarios. But with this tool, I'm going to leave this up for just a second if you need to kind of jot this down, or if you want to click a picture with your phone or what have you. But it's a nice little tool, and it references the NFPA 5000 and the International Building Code 2015 edition as well. So interactively, you would select and enter the data of your building type, the height of your building, and it really kind of does start to point you in what code you want to meet, and then it would start to point you to the actual code book definition. So it might ask you to go to, hey, your scenario, go to chapter 14.602.2.3, and it'll direct you right to a code that will kind of refer you to some of the requirements that you might need. It's just a nice little tool to have at hand if there are any questions or trying to meet some of those situations that you're up against. That concludes the actual presentation, the AIA presentation, but I'd like just to take a quick second, if you don't mind, just to let you know that as a Johns Manville employee and one of the team members here, we have an incredible staff of really talented folks, and we have lots of resources that we can share, everything from our product management to technical, and our customer services is supreme as well. But we have the solutions that we've been discussing here today, and we offer the largest portfolio of insulation products. We would really appreciate your consideration when you're looking at fiberglass, mineral wool, spray foam, and when you're writing your specs, if you would mind including us in your specifications, and that would allow our contractor base to help you out with bids and give you some competitive information as well. But our portfolio stretches from fiberglass, mineral wool, blown-in fiberglass materials, spray foam materials, the polyiso boards, the interior and exterior continuous insulation polyiso boards, and then tile backer boards, which are actually waterproof polyiso boards as well. And then we have some other exciting stuff that we're working on in the industry as well. So just wanted to share that with you. I thank you very much for your time. I'm going to pass the ball back over to Kim and let her take it over from here.
All right, thank you, Dwight. So before we dive into questions, I do want to go through a couple more resources we have. All of the webinars that were part of this AIA series are now available on demand on our website. Today's webinar will be recorded, or has been recorded, and will also be available on the site coming soon. We will have to get it posted, so it's not immediately available. You can access these webinars from the building installation page from jm.com. If you look in the left-hand menu, you'll see a link that says webinars. You just click on that and it'll take you straight to our webinars page that hosts all of these AIA certified webinars. One thing to keep in mind, if you do watch the recorded version, we don't have a way to get you the learning credits for it. So it would be strictly for educational purposes and not for earning learning credits. In addition to these webinars, if you're looking for more information or if you have really detailed questions, and we did have a number of questions submitted that we're going to reach out to you offline because they're a little too detailed for today's presentation and they would be better to have in dialogue, you can actually reach out to our JM TECHCONNECT team. You can access them through a phone call, which is 1-800-654-3103, or you can email them at bispecservices@jm.com. And we actually have resources designated specifically for architects to help you guys as you sort through your system specifications. And so this is a great resource for anybody who's looking for a person to talk to about that. If you'd like an app to hold all of our data sheets and safety data sheets, we recommend JM Smart Binder. You can get it in the App Store for smartphones of Apple or Android in nature. And this allows you to actually just access all of our data sheets, documentation for our products right there from your phone. It's very quick and easy access. We also have a continuous installation page. So if you're looking for materials specifically for continuous installation, this is going to be a great resource for you. It's jm.com/CI. And then a certificate of completion. This will be in your inbox by Monday. And for those of you who submitted your AIA number when you registered for this event today, we will submit your, we'll declare your points or your learning credits for you. For everybody else, you will get a certificate of completion if you need to submit in a different manner. So with that, we're going to take it to questions. For everybody on the phone, we will continue to answer questions until either all of them are answered or it's half past the hour. Anything we don't get to today, we will reach out to you privately to get your questions answered. So Jerry, are you ready for your first question?
I am ready.
All right, excellent. So the first question is, can you speak to the cost of various continuous installation strategies?
Definitely, there's definitely a variation. I don't want to speak on behalf of numbers, but I would say that it's pretty common that if we were to have a higher performing material, that it would cost a bit more, and that's just generally speaking. But as you can see, some of the lower lower melting point and the lower R value materials are typically less expensive than that we presented today, whereas the higher performing materials are obviously a little bit more expensive. It's a difficult question to answer. If I were to give a price, it may vary per region, and our call extends out across the country today, so I don't want to mislead anyone in giving an actual price. But what we can do is if the person who asked that question would like to contact and use our resources for contact, we will connect you with the local representative to help you with comparisons of materials.
All right, excellent. Thank you, Jerry. The next question is, on a renovation, when you put continuous insulation on the exterior walls, how important is the permeability of the insulation?
That's a good question. That actually would depend on the climate, number one, of where you're designing. But normally, you would want to leave an air gap in between the insulation and the cladding to allow for drainage, especially like we discussed earlier, how we're pushing that relative humidity and that condensation point out to the outside of the building. You have to determine, are you designing for a warm climate, cold climate, but you would still want to leave an air space in between to allow that moisture that does collect or condense to exit the building.
All right, thank you. The next question is, does continuous insulation eliminate the need for cavity insulation?
Another great question. Actually, if you look at your building code for thermal insulation, and I know that certain building codes are different chapters, but if you look at your thermal insulation codes, depending on your structure, there are opportunities to just install continuous insulation on the exterior of a building and not include cavity insulation. I will warn you that there are some other properties that you may need to take in consideration, though. If you're thinking about not installing any insulation in the cavities, and the insulation itself, as far as bats are concerned, what we call bat insulation in between the cavities, they do give a great R value or resistance value, but they also help with sound attenuation as well. So again, we need to consider what your design criteria are so that we can answer that question, but that's a great question. You are able to achieve, with a thicker material, you are able to achieve continuous insulation only on the outside of the building per building code.
All right, thank you. The next question is, will continuous insulation eventually apply to residential roofs above the sheathing and eliminate ceiling level insulation? That's
the crystal ball question, I guess. I don't know if it will eventually require that to be done. I know that in certain areas there's been a reflective material that's been applied to the underside of like a radiant barrier, if you will, being applied underneath the sheathing. At this point, there are options to utilize spray foam in attic spaces to create the envelope from the walls up and into the attic space. So there are many options to insulate. I don't know if there's any requirements I've heard of at the moment that require it for residential applications on top of the sheathing, though. That's there are ventilated, insulated. Trying to remember. Forgive me for my delay in my brain activity here, but there are vented polyiso boards that you can apply that would allow polyiso to be on top of the roof deck and still vent. So that there are options out on the market. For the person who asked that question, if you want to contact, we can actually offer you through our Johns Manville data sheets, we can offer you a solution for that.
All right, thank you, Jerry. The next question is, does AP foil qualify as water-resistant barrier on the exterior of buildings?
It does. As long as the joints are taped, it's a foil face, and then the actual tape itself, taping the joints and over the fasteners will create an air barrier and moisture barrier, vapor barrier. So that is one of the benefits behind the AP foil material.
All right. How can a design team identify the optimal exterior envelope system for a particular region?
Optimal design for their region. As far as the exterior, repeat the question for me real quick, please.
Yes, absolutely. How can a design team identify the optimal exterior envelope system for a particular region?
If you were to, again, it's more or less the energy code and the code book itself will yield you to solutions. They will not tie you into one solution. For instance, if you have a light gauge steel framed building, I'll just use this as an example. They will give you options to introduce continuous insulation with different levels of cavity insulation to meet the building requirement. They do leave it open so that you have the options to put continuous insulation, and not have cavity insulation, or you can do the combination of many different options there, thicknesses of insulation. So to get the optimum, that actually would depend on where you're located, I guess, and what materials are best available to you. Again, if you would like, for the person who asked the question, please contact us, and we can put you in with a local rep as well to help execute some options or some solutions for that.
All right. The next question is, can you address CI and how to insulate reveals (parentheses inset) for windows and doors? So,
that's, again, this a little on the specific side, but as far as reveals are concerned, if they're deeply inset, the option of returning insulation would just be in the detail of the actual window sill, jamb, and head, and then actually treating the corner. I would say that that's going to definitely go into a lot of different levels of detail here, but your flashing details, your cladding systems, but the continuous insulation being returned back into a deep set window is one option, and that's something that we would have to kind of sit down and actually look at. But to return it back, as long as you have something to fasten the insulation to, depending on the depth. Obviously, it's a little bit of an open-ended question, but hopefully that helped.
Yes, absolutely. So the next question is, what is the main reason continuous insulation is broken?
Continuous insulation, main reason it's broken would actually be window and door openings, and you really, again, kind of going back to the details of how we treat those returns, I guess. But as far as up and over, if we take, for instance, up the walls and over and on top of the roof, in the commercial application, you could still continue to apply insulation, up and over the top of the roof, which is done pretty regularly. But just the joints themselves, if you're using boards, it would be a joint. If you're using the spray foam, there's really no interruption because the spray foam application actually marries to itself as you pass by and apply actual spray foam. The other breaks, as far as mineral wool is concerned, would be just whatever struts you're using to actually hold the mineral wool up and securing it in place.
All right, thank you. The next question is, what conditions require a permeable system versus a non-permeable wall system?
It's permeable versus non-permeable. I would say that your actual construction type. Permeable systems, I would, again, referencing back to the presentation since it's fresh in everyone's mind, a permeable system as far as continuous insulation would be like a mineral wool product, but you would want to, again, apply an air barrier or weather resistant or water resistant barrier as well behind it, so that you don't have the penetration into the building. Whereas some of the foams and other boards that you can seal off are non-permeable. So I'll reference that. But if you have an open air building, or I'm not sure why you would want to insulate an open air building, but really that's a little bit open-ended as well.
All right. The next question is, many exterior cladding cannot be installed to or below finish grade. Insulation must be continuous. How do we protect the exposed insulation from dicers, weed eaters, and snow shovels?
So if you have an opportunity, again, your exterior materials may need to change, but a lot of times I see either a layer of stucco or some type of a finished system being applied over the continuous insulation, even if it's buried below grade. It could be stucco, it could be stone, it would be a stone veneer, but again, I'm not sure what aesthetic you're looking for, but having some type of a hard surface to cover over and stepping that veneer out, and again, giving kind of a separation from the wall so that any kind of collection of moisture would be able to escape out would be my first thought of a solution.
All right, the next question is, we have a tilt-up concrete building with an applied stucco that is getting water penetration and separating. Do you have any suggestions for remedies?
If you have an applied stucco that's separating and cracking, that could be a number of different problems. That's really not related to this specific topic, but what I would say is the stucco either dried too fast, it was a hot day, didn't have enough moisture content to set up and actually adhere. But there are some repairs that can be made. If it's separating really bad, and it's creating large gaps, then I think a deeper attention might need to be considered to resurface the stucco. You don't want to have moisture, getting behind the stucco, because then it would spall away from the wall and begin to expand and contract if there's in a colder scenario, or any type of water-driven scenario.
All right, thank you. The next question is, what do you suggest to insulate a load-bearing masonry, brick, and/or block wall that will have new exterior metal composite and metal siding installed over this masonry? It's a two-story industrial building that was constructed in the 1970s with no interior insulation and is located in a northern climate.
If you're going to be installing over the top of the existing brick, I would say that a continuous insulation could be used. If you're going to have another additional structure on the outside, similar to the examples that were shown in this presentation, again, there were some separation, some thermal breaks that were offered as options, whether it be the fiberglass thermal breaks or the thermal isolation barriers. But in regards adding continuous insulation on the outside and trying to create enough of an R value to do a great job, and then also thermally isolating the two structures between, so there's no transmittance or no creating a thermal bridge back to the block and heating up the block from the metal clad system. So I think we gave a good example of those in the slideshow earlier.
All right. The next question is, can you talk a little bit about installation guidelines for stone wood exterior profiles?
So stone, if I'm not mistaken, I think Stonewood is a name brand of a panel system. I'm going to refer you back because it's very, again, somewhat similar to what we're looking at in as far as our slideshow with the two structures. They have their own GERTS system, and they have their own application. I'm going to refer you back to the actual manufacturer's details, their installation details, because they have their own structure system for their particular panels. If the person who asked this particular question, if they are interested, reach out to us and we can kind of look at some of those details, maybe offer a solution for what type of continuous installation to use in that system.
All right, thank you. The next question is, what is the best practice for a stucco finish wall with a continuous layer of rigid insulation of exterior sheathing?
Depending on what type of stucco you're using, the old traditional 3-coat systems was a wire lath. So if you had a continuous installation on the exterior of the, and you're sealing everything off so that there's no vapor that's going to be transmitted through the actual continuous installation, the old wire lath scenario, so that you have something for the first coat of stucco to bite into, the scratch coat, and then brown coat and then finish coat. But if you're going into some of the newer modified stuccos, there's obviously some other materials that are on the market, some meshes that you can actually attach over the top of continuous installation boards and then apply stucco. So it really does depend on what type of stucco it is, and we would need to, again, compare some manufacturers' recommendations of their applications on whether they're using a mesh or a wire lath.
All right, the next question is, what should you look for during site observations to ensure an effective installation?
That's a great question. If you can recall back again, making sure that whichever type of material you select, if the joints are recommended to be taped, make sure that they're taped, make sure there's no penetrations that are not sealed off. As far as the continuous insulation is concerned, if it's mineral wool, make sure there's a WRB and an air barrier beyond. Make sure that there's an air gap for moisture to be taken, and also flashings. Flashings are extremely important in these scenarios to remove the water away from the building. That's off the top of my head. Those are all the, some pretty major points.
All right. The next question is, do certain types of rigid insulation give off toxic gases, if they burn in a fire, and if so, should they still be used?
That's a great question. I would say that when you have plastics and they burn, or certain chemicals and they ignite, the potential for toxic gases are there. Are they harmful? To what levels? I'm not sure. I don't have that data in front of me. But I would say that if we could get back to that particular person who asked that question, I would go back to some of my technical resources to help answer. But anytime you burn a chemical, the potential for toxic gases are there. So difficult question to answer. Sorry, I don't have that one at the top of my head.
All right. The next question is, even though continuous insulation is required by prescriptive method of compliance, when you use ComCheck or ResCheck to prove compliance, you rarely need the continuous insulation to comply. Are you still finding many projects that do not use continuous insulation? Yeah,
and depending on what year your ResCheck and ComCheck are you're using, I would say that if you're substituting and you're using different methods and prescriptive methods or what have you, there's obviously some trade-offs that you can use. I think that depending on as we progress, I should say, with the building codes becoming more strict and more folks or more energy codes are being implemented, I think that you can pass the requirements to get a permit. But I think today we've kind of given some pretty prime examples of, even though we have some trade-offs and we may increase the efficiency of our air conditioning systems or play around with our lighting options, are we still really resolving the issue of thermal bridging? And I think that's the question as a design professional that hopefully that you can answer after today's presentation. You make the air conditioners work harder, but it's still losing a lot of energy. So I'm not sure that you're gaining anything, although you can still meet your permits. You can get your permit for the building and pass the code. I think that there's definitely a trade-off in that particular scenario.
All right, the next question is, this person is looking for input and or confirmation of their calculations regarding a retrofit of an existing wood frame buildings with existing insulation in the framing with regard to managing the dew point to keep it out of the board framing. Can you give them some input as to where they might be able to find input or confirmation of their calculations?
Yeah, so I would say that that's something that I would refer back to our technical staff, and I would there may be some resources that we could dig up for that particular person. If you don't mind, we'll reach back out and answer that question and get some more detail and hopefully be able to share some sources for them.
Absolutely, I'll take a note on that one. The next question is, how much, if any, does exterior insulation in roof or walls affect interior acoustics?
Great question. Depending on the actual material that you're using, would affect acoustics. For instance, if you've joined us in the past for some of our past presentations, we've actually talked about acoustics, and I think last week, and it was pointed out that the mineral wool products are very good for acoustic ratings, STC ratings. Some of the foam boards are not as good. They don't necessarily block the sound because they're more rigid. So I would say that if you're looking for a better or best scenario, your best scenario would be mineral wool products to help with acoustic STC ratings, specifically for noisy areas or high levels. Fiberglass also works great in inside walls, but if you're looking for continuous specifically, mineral wool would be your best option.
All right. The next question is, what can be done to reduce R-value loss of polyiso boards as they shrink, thus creating gaps between the boards? I know that cover boards can work on roofs, but what about walls?
So when you're referring to shrinkage in the curing process on polyiso, for wall systems, for vertical applications, obviously for wall systems, we're actually taping those joints. So the joints should be already sealed. So even if there's a small gap, and these gaps are typically pretty small, if there's any shrinkage, there's not a ton of shrinkage on the polyiso boards, but that tape actually still will stick. The facer, will still stick, and with the tape and the facer combined. So there's really not a ton of loss there. I think you look at your construction applications, and if someone were to try to cut a board, you could have a little small gap there, and you can actually apply a little bit of foam, spray foam up in between the gaps if they're too large. But as far as the vertical applications, I think that you're sealing them with a tape scenario. I think you're going to have minimal loss.
Awesome. Thank you, Jerry. So the next question is, can you discuss the proper type of brick anchor to be used with CI? I've seen corrugated anchors installed first, then rigid insulation is pushed over the anchor, causing damage to the insulation. This also leaves gaps between the CI boards, and the CI is not in full contact with the sheathing.
So in that particular case, there, let's see, with your anchors being strapped back to the structure, and you're pushing that against your continuous insulation or your boards, it really comes down to the care of the application. You know, when the anchors are applied, I know that folks are being asked to apply building materials faster, and sometimes not paying attention to that application, you know, could cause more damage than good. But if there are larger gaps, you know, sealing that off again with a spray foam can, and if it's large enough to seal off the spray foam, then I would actually apply some of the seam tape over the top of it as well to try to help alleviate any type of penetrations. But as far as the application is concerned, it really comes down to the actual care. A lot of times, if those tiebacks are adjustable, you know, try to hit the seams as much as you can, and then just try to, you know, take the time to create as little of a hole as possible when you're poking those tiebacks through the actual foam board itself.
All right, thank you. The next question is, should insulation joints be taped to maintain the building thermal envelope?
Yeah, I think we actually answered that one a couple of times. So yes, I would suggest, you know, as far as rigid boards are concerned, taping the rigid board seams together, that's definitely a yes. You know, spray foam applications don't need to be taped, obviously, because they're all one piece, but mineral wool typically doesn't get taped. It just abuts and is more of a friction fit. So to answer that question, I believe we covered that during the presentation.
All right, the next question is, relative to the thermal bridging chart and example, why are the steel studs assumed to be 25% of the wall and the insulation only 75%, when in fact the steel studs, while highly conductive, are far thinner than wood studs?
It's just we have to have an example of a standard wall system, and to his point, the person who's asking this question's point, obviously, depending on the stud spacing, the stud, if it's a 12 on center versus 16 on center, or 12 on center, or 24 on center, obviously, the wall could vary. But just for the purposes of this particular example, we kept everything consistent, and we just said, hey, you know, a standard wall system, and we pretty much added the studs together to say it's about 25%. Obviously, it depends on the scenario, and if you can imagine, if it's more than 25% of stud coverage in a wall, then you're going to lose that much more energy coming out of the building. So, you know, understand the question, but I think it was just so that we could provide an example of a standard system and keep things consistent across all the examples.
All right. Next question, is there a way to achieve continuous insulation without applying exterior rigid insulation?
Yeah, I believe we kind of maybe covered that a little bit as well. If you didn't want to apply exterior insulation, there's an option for interior, depending on the scenario. Again, if it's a historical restoration or something where we can't get to the exterior, you may have an opportunity, if you're renovating that particular space, to apply it on the inside instead of the exterior.
All right. Can you explain drainage plane a little more?
Drainage plane a little more. As far as the drainage plane is concerned, when we referred to a drainage plane, we were basically referring to a rigid insulation where a cladding system was going to be applied on the exterior of a building. Let's say, for instance, it's a rain screen, like a metal panel system. Most of those, if they're open systems, are considered to be rain screens. moisture can penetrate or make its way behind the panels. And if it hits the actual rigid board systems and they're sealed off properly, that would become a drainage plane. And therefore, it would hit that board and then drain down to a flashing and then exit the building. Whereas the mineral wool material example I gave, the mineral wool material is not a drainage plane because it is a little bit more porous and vapor open. So therefore, if a lot of times if it hits the mineral wool, it'll basically only travel a short distance into the mineral wool and still drain out, again, to the flashings. But that's what we consider drainage plane to be.
All right, thank you. The next question is, are there compatibility concerns with the adhesion of rigid insulation to a fluid-applied air barrier?
Potentially, depending on the application. I think that there could be some tests conducted, some field trials conducted, but it depends on the tube materials. And obviously, it's a great question. It's a little bit broad because I don't have any specifics. If it's a fluid applied material and you're overlapping, we just need to make sure that they're chemically friendly, if you will. But that's something that we would have to deep dive into as far as products are concerned to kind of get the compatibility of the two products that we're referring to.
All right, the next question is, how do you handle moisture intrusion in climates that have both warm and cold months?
Great question. I would say that from my experience, some of the most difficult climates to design for are actually climate zone 4, unfortunately, because it does have almost equal heating and cooling days. And I think that that's where you have to make a determination. If you recall, one of the slides that I referred to is the air barriers being continuous around, and I said, hey, you put an air barrier, an option would be ideal, put an air barrier on both internal and external wall assemblies, but just let one breathe, so that it's more vapor permeable, so that it has an opportunity to dry. That would be one of those scenarios. Could be a possible solution, but it is a difficult scenario. In certain cases, I've had architects who in those areas have told me that they actually don't even apply vapor barriers in place because it drives through and it's either handled conditionally, but that's not what I recommend. I would just say that's what I've been told. But I would say that the potential for controlling that moisture inside out would something that you need to pay attention to from a design perspective.
All right, thank you. The next question is, CI is tricky with masonry veneer and air spaces. The brick is pretty far from the attachment. Can you speak to some brick detailing methods?
As far as you say the spaces are pretty far from you repeat the last part, the space is pretty far from?
The brick is pretty far from the attachment. Can you speak to some brick detailing methods?
I would need to get back to you on that one. Weep holes are typically used if depending on the height of the building and obviously gutters on the outside of the building would help, but continuous insulation and having an airspace is extremely important so that you have an opportunity to allow moisture to exit the building again, and utilizing your flashings and weep holes. That would be my suggestion, is to look at the entire design of the building itself. You have to consider not just the continuous insulation in that particular part as far as the masonry is concerned, but the airspace and your flashing details and how you're moving the water out of the building.
All right. The next question is, with open joint exterior panel systems, what has the industry experience been with insects and other critters entering the cavity through those gaps?
From what I've seen in our partners in the metal clad industry, those spaces are relatively small. I haven't seen a space large enough to get I consider a critter being someone who makes a home, like a squirrel or something larger. So I don't know. I mean, the spaces are typically small. I would suggest if there's a concern regarding that, look at how that system is fastened, because a lot of times the mounting systems itself kind of close off that gap and keep insects and other things from building nests in there. And they have perforated flashings similar to a soffit on a house or something. The water can still drain out, but it doesn't leave a large enough hole so somebody can get up and build a nest. So I think that explore possibly the details and the materials being used with your cladding system itself. And if you need a recommendation, I can give me a call or give us a contact, and we can help recommend a couple of our cladding companies that could help you out as well.
Excellent. The next question is, if you use CI on residential construction, do you need to wrap the house first and then install the CI, or can you install CI directly onto the structure? Example, plywood.
So if you are using a continuous insulation over a plywood, you're going to want to make sure that you use a material that is going to act as an air barrier and a vapor barrier at one time, so that there's no penetration that's getting into the plywood, so you don't have to add the house wrap. If you want to add the house wrap, I don't think it's going to hurt anything. It's not going to really, vapor's still going to move through. But depending on if you're looking like a Tyvek or something that's permeable, I don't think it's going to be a large issue. But if you're wanting to use a continuous insulation that's going to act as an air barrier and vapor barrier, the consideration is making sure that everything's sealed off properly, so that no moisture gets back to the actual plywood surface as well.
All right. The next question is, with a new 12-inch reinforced concrete roof deck, is a vapor barrier a good practice on top of new concrete deck in order to prevent moisture curing out of the new concrete, not to migrate into the roofing system, including roof insulation?
Great question. Puts me back to my roofing days. So my question back to this particular person is this a lightweight structural concrete, or is this a traditional concrete? Makes a huge difference in which direction that answer would go. Simply, yes, typically vapor barriers are used, but with lightweight structural concrete and the aggregate absorbing more moisture content, it tends to have a longer drying period, not curing, but drying period. So you have to be cautious and make sure that the relative humidity of the concrete is susceptible and will accept the vapor barrier that you're planning on putting down. But ultimately, the answer yes for vapor barrier. The answer is caution, because you need to understand what you're applying to and how much relative humidity is in the concrete itself.
All right. The next question is, what type of vapor barrier, if any, is used at the interior of the wall with exterior continuous insulation?
I think it depends on what type of exterior insulation you're using. So I have to think for a quick second here. If you're using a vapor barrier with continuous insulation, again, depending on what type of material you're using, because some continuous insulations, like for instance the foil-faced boards, could be also already a vapor barrier in itself. If you're putting a vapor barrier on the outside and inside, again, you want to make sure that one's vapor permeable so that you can dry out and don't create a moisture sandwich in the wall. So I'm not sure that I would put one on. If I have a continuous insulation that actually acts as a vapor barrier, I'd probably just do one, not take a chance on doing both.
Excellent. Well, Jerry, thank you so much for your time today. It is 1:30, so we're going to go ahead and call the webinar. We do have a number of questions we were not able to get to today. So if we didn't get to your question, we will reach out to you independently to make sure your questions do get answered. For everyone else, thank you for joining us today. Your certificate of completion will be submitted to your inbox by Monday. And if you submitted your AIA registration number to us when you registered for the webinar, we will submit to AIA for you. So everybody, thank you for your time and have a great weekend. Stay safe, stay healthy, and we will be with you in the next couple months with new webinars.